In Module 1, Lesson 23, we're going to take a look at solution sets to simultaneous equations. So the instructional outcomes are to create systems of equations that have the same solution set as the given system, and two, to understand that adding a multiple of one equation to another creates a new system of two linear equations with the same solution as the original system. So we're going to take a look. In class, the students had an opportunity to look at the opening exercise to begin class, and it says, here's a system of linear equations. Verify that the solution to this system is 3, 4. And so we'll take an opportunity and make that demonstration. So we have two equations, A1 and A2, whereas in A1 it shows that y equals x plus 1, and then y equals negative 2x plus 10. This would be identified by the student's teacher as the substitution method that we'll model here. So what I see is I know that y is equal to x plus 1, and here is a y in the other equation. We're asking students to remodel or resubstitute this as saying x plus 1 equals negative 2x plus 10. And so then the student's going to proceed at that point to solve for x. So we would add 2x to both sides. That's going to give us a 3x plus a 1 equals 10. We'll subtract 1 on both sides. So minus 1 and minus 1. That's going to give us 3x is equal to 9, and then we will divide by 3 on both sides. And so then x will equal to 3. So we can see up here we have our 3, that is confirmed. All we want to do now is confirm our 4, and we can do that by taking either one of the equations. Does not matter which one. Let's say we take the first one, y equals x plus 1. If I plug in that 3, so 3 plus 1 equals 4. And it's also worthwhile noting that it doesn't matter which equation. So if I chose the other one, y equals negative 2x plus 10, and I put a 3 in here, negative 2 times 3 plus 10, well, this gives us a negative 6. I can add 10, and y still equals 4. So it's worth mentioning that students can choose either equation, the one that they feel is easier or gives them the most success in passing that particular problem. So that confirms 3, 4 as our given answer. So there'll be 3 other problems we'll look at in this video. The next one will be example number 1, where it says solve the system of linear equations algebraically. They want to know, why does the elimination method work in this particular piece? Well, if you notice and you look at it, nowhere in here do we have what y equals. So one thing that we can do is we can take and do something called elimination, where we have the original system here. We're going to create a new system and use that new system to develop a solution. So when I'm working with elimination method, what I want to be able to find is something that's going to vertically eliminate the x's or vertically eliminate the y's. Well, right now, whether I add or whether I subtract, we're not going to eliminate one of those variables. So what I can do is I can choose to multiply, let's say, this second row here by 2. So I'll multiply this whole row here by 2. As for the first row, I'm going to leave it exactly as it is, the 2x plus the y equals the 6. Now when I multiply this whole row by 2, well, x times 2 is 2x. 2 times negative 3y is negative 6y. And then 2 times negative 11 is negative 22. Now what I can note is that if I was to put a minus sign in front of this equation here, I would be able to subtract these two and get 0. So 2x minus 2x is 0x, hence the elimination method. 1y minus negative 6y is a positive 7y, and then 6 minus a negative 22, so 6 plus 22 is equal to 28. So now what I have is I really just have 7y equals 28. Divide both sides by 7, and so y is going to equal to 4. So I know for my solution, y is equal to 4. I want to take an opportunity now and determine what would my x value be. And so then I'll go back and I'll choose either of the original equations. Doesn't matter which one. We'll choose the first one. And so if I choose 2x plus y equals 6, and I now know that y is equal to 4, I can say 2x plus 4 is equal to 6. Subtract the 4. And so now 2x is equal to 2, and x is equal to 1. So here is my solution written as an ordered pair. I would have 1, 4. And this is using the elimination method. First, if we go back and compare to the substitution method, where we place one equation into the other equation to solve that. In exercise 1, exercise 1 and exercise 2 is essentially the same, but what you'll notice in exercise 1, they want us to focus on eliminating the y variable as opposed to the x variable. So if I see here I have a 3y and this is a negative 1y, I want to consider multiplying this equation by 3. So what would my new system look like? I would have 2x plus 3y equals 7 here. 3 times x is 3x. 3 times negative 1y is negative 3y. And 3 times 1 is 3. Now, remember, the goal here is to eliminate. So I'm asking myself, if I want to make this column go to 0, should I add them together or should I subtract them? Well, I want to add them because I know that 3 plus negative 3 will be equal to 0. So if we solve every column, 2 plus 3 is 5x. Again, the 3 plus negative 3 is going to be a 0y, and 7 plus 3 is equal to 10. So what do we have? We have our 5x equals our 10, and x would equal to 2. So we know for our solution here, x equals 2. I want to choose one of the original ones here. This time I'll choose the second one to determine what y would equal. So if I selected x minus y equals 1, the original piece, and I know x is equal to 2, I can say 2 minus y equals 1. Subtract 2 on both sides. So negative 1y is equal to negative 1. Divide by negative 1, and y will equal to a positive 1. And then so I can say my solution is 2, 1. In exercise 2, we give the students an opportunity to have the same system. So same system we looked at last time. But this time, we want to give them the opportunity to eliminate variable x. The goal of this exercise is for a student to realize you can eliminate either the x or the y first, and when you get to the solution at the very end, the solution will be the same. So we already know the expected solution is going to be 2, 1. We just want to confirm that. So if I want to eliminate the x's, this time I'm going to choose to multiply this by, let's say, 2. And so when I leave the first system or first equation alone, I have my 2x plus my 3y equals my 7. But at the bottom, 2 times x is 2x minus a 2y equals a 2. Again, I'm asking myself, how do I make this part go to 0? Do I want to do 2 plus 2? Well, that's 4. But 2 minus 2 would equal 0. So we're going to subtract. So 2 minus 2, here's my 0x, my 3 minus my negative 2 is going to be a 5y, and 7 minus my 2 is equal to 5. So 5y equals 5. I divide by 5 on both sides, and y is going to equal to 1, which is what we want to see, because here's our y equals 1. And now if I wanted to go in and solve for x, let's say I choose the second equation like last time, x minus y equals 1, and if I know that y is 1, so x minus 1 equals 1, I will add 1 to both sides, and x equals 2, which is our other piece right here in our solution. So that gives you a little bit of a background on solving systems. One, we began with a review of substitution from a previous lesson, and then secondly, a more in-depth focus on the elimination method. Again, if you have more questions, feel free to contact your child's teacher and ask for further questions and so forth, but hopefully this will help you get started in helping to work with your homework problems on this section.